The question is, A. Explain why you can't use the limit laws to evaluate the limit as x approaches pi on 2 of 1 on cos x minus tan x. And B. Find the limit in A by bringing the expression to a common denominator and multiplying top and bottom by 1 plus sine x. Well, the limit laws say that you can do the limit of the parts separately as long as the two separate limits exist. So if those two separate limits exist, I could write it as the limit of 1 on cos x minus the limit of tan x. But those two limits don't actually exist. Tan x doesn't actually exist when x is pi on 2, and cos x is 0 when x is pi on 2, so I can't do 1 on 0. To write this formally, let's put it down. A. The limit as x approaches pi on 2 of 1 on cos x does not exist, since the bottom is 0. The limit of the bottom is 0, so it does not exist, since the limit of x approaches pi on 2 of cos x is 0. And the limit as x approaches pi on 2 of tan x also does not exist, since tan of pi on 2 doesn't exist because it's actually infinity. So that's why we can't do it. So we cannot write the limit as x approaches pi on 2 of 1 on cos x minus tan x. So we can't write that by separating the limits. So limit as x approaches pi on 2 of 1 on cos x minus the limit as x approaches pi on 2 of tan x, because those two things don't exist. Yes, and I'll just underline the fact that we cannot write that so that the reader is aware that I haven't written something that's wrong. So now let's do part B. It says to bring the expression to a common denominator. Well, let's see. 1 on cos x is minus 1 tan x needs to be brought to a common denominator. Well, let's do that. 1 on cos x minus, well, tan x is sine x on cos x. And now it's over a common denominator, so that's 1 minus sine x on cos x. And now it says to multiply top and bottom by 1 plus sine x. So let's do that. Let's change this to something with 1 plus sine x multiplied on top and bottom. So we need brackets here. 1 plus sine x times 1 plus sine x. Now 1 minus sine x times 1 plus sine x would be 1 minus sine squared x, because we've got a difference of two squares, over cos x 1 plus sine x. And 1 minus sine squared is really cos squared. So cos squared x over cos x 1 plus sine x. Okay, so now we've got a cos squared on the top and a cos on the bottom, so we can cancel those out to just give me cos x on 1 plus sine x. And that's great, because when I do those limits, they'll both, the top and the bottom both exist, and neither of them are, well, the bottom one's not 0, and that's all I really care about. So let me start a new page and actually figure out what the limit is. So the limit as x approaches pi on 2 of 1 on cos x minus tan x is equal to the limit as x approaches pi on 2 of cos x on 1 plus sine x, because we've just figured out that 1 on cos x minus 1 tan x is the same as cos x on 1 plus sine x. And that's just can be made by subbing in the pi on 2, so that's equal to, oh, let's go back, yes, that was right, I did copy down my formula correctly, so that's equal to the limit as x approaches pi on 2 of cos x over the limit as x approaches pi on 2 of 1 plus sine x. I can split that up using the limit laws now because both of those limits exist and the bottom one's not 0. So that's just cos pi on 2 on 1 plus sine pi on 2. So let's think by drawing our unit circle. Pi on 2 is here at the top and the coordinates there are 0, 1. So cos pi on 2 is the x coordinate, which is 0. Sine pi on 2 is the y coordinate, which is 1. So 0 over 1 plus 1, which is 0 over 2, which is 0. And so that completes the question.